Well, greetings, Mr. Colazar's class. Just a little introduction video information on how to work through our worksheet packet. Just some quick information ideas to go through each part. Now remember, carbon can make up to 4 covalent bonds, either to another carbon or to hydrogen. So hydrogen can always just make 1 covalent bond. So that'll be kind of our starting point here. So on worksheet 1 is where we're just going to start off with our straight chain beginning alkanes. Now our organic prefixes, using your gold packet, have our meth, eth, prop, bute, pent, hex, hept, oct, non, dec. So we are 10 there, always ending in ane. And then we've got our equation 2n plus 2 to find out how many hydrogens. So if we have butane, bute is 4. So we'd have 1, 2, 3, 4 carbons with a hydrogen at each section. So eventually we will get used to not having to put those hydrogens in after this first worksheet. So from there, our 4 carbons, 1, 2, 3, 4, our skeletal structure is going to just show the carbons. And to show it, we're going to have 1 going up, 2, 3, and 4. Now to show this would be our first carbon, second, third, and fourth, and that's all we need to show for there. Chemical formula, we've got 4 carbons. How many hydrogens do we have? 2n plus 2 is 10. To count them, 1, 2, 4, 5, 6, 7, 8, 9, and 10 would give us that. On our second one, C7H16, 7 carbons. And then to each a hydrogen. So there would be a hydrogen at each of our spots, all the way across to the opposite side. Or skeletal structure, 1, 2, 3, 4, 5, 6, and 7 would be our carbons of just showing them without our hydrogens. Name for this one, 7 carbons, hept, and always end in ane, A-N-E, heptane. Moving to worksheet 2, branch chains. Branch chains, parent chain is the longest continuous. Substituents are our side groups, or the side chains they're known. We have 3 of them, meth, eth, and propyl. Our methyl, ethyl, propyl are 1, 2, 3 carbon chains. In kind of our format, where they're located at, the name of the side chain, and then the name of the parent chain. If there are 2 or more, we're going to include those Greek prefixes from your gold packet also. So to get us started, 2-methylhexane. We start at the end of the parent chain. So hexane, as we're working, is going to be now a 6 carbon chain, 1, 2, 3, 4, 5, and 6 carbon chain. And on the second, we have a methyl group, a 1 carbon chain. All we're going to do is draw on a line going up and down there. So our methyl group is just a 1 carbon line. Our ethyl group is going to be a 2 carbon line, so 1. And then our propyl group is up, over, and back up. So we've got our 1, 2, 3 as we're working there. If we have 2, 2, 3, 3 tetra, that's 4 methyl groups, and butane is our parent chain. Butane being a parent chain, 1, 2, 3, 4 carbons, 1, 2, 3, 4, a methyl group at the 2 carbon, a second methyl group at the 2 carbon, at the 3rd carbon, a methyl group, and at the 4th carbon, methyl group, giving us 1, 2, 3, 4, all 4 methyl groups in butane. For our chemical formula then, we have 4 carbons from the butane, plus 1, 2, 3, 4. We have 8 carbons total. How many do we need hydrogen-wise? 2n plus 2. 8 times 2 is 16, plus 2 is 18. So in the end, that's what we're looking for there. On 4, nonane, our parent group, and then 4, 5 dipropyl, 2 propyls, nonane, 9 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then from there, 4, 5 dipropyl off carbon 1, 2, 3. Off the fourth carbon, we have a 1, 3. And then off the fifth carbon, another 1, 2, 3 carbon chain. So in the end, nonane, 9 carbons plus 1, 2, 3, 4, 5, 6. That would be C15 times 2 plus 2, H32 for nonane. So as we're working through all of these, look at what that parent chain is. Octane, 8. Dimethyl, there are 2 methyl groups, the 2 and the 4, and diethyl, there are 2 ethyl groups at the 3 and the 5. So octane, 1, 2, 3, 4, 5, 6, 7, 8. Oops, 7, 8. And then from there, at the 3 spot, an ethyl group, 1, 2, 3, so an ethyl group. And at the 5 spot, 1, 2, 3, 4, 5, an ethyl group. And then the 2 and the 4, dimethyl, both methyl groups there to get us to our number of carbons. How many do we have total for our formula? Octanes, 8, plus 1, 2, 3, 4, 5, 6 is 14 total. So C14, and times 2 plus 2, 28, 30. On backside worksheet 2, naming the following compounds, we're going to be looking at finding our first part, our longest parent chain. So in this case, we've got a parent chain would be here, but here's the catch. We can number it backwards, 1, 2, 3, 4 carbons instead of 1, 2, 3, 4 carbons. So we get to the lowest number here. So in the end, off of the second carbon is a CH3. That is a methyl group. So our parent chain, butane, and off the second carbon, a methyl group. So 2-methyl, and then butane. C5H12 would be our chemical formula. Now from there, our next one, parent chain 1, 2, 3, 4, longest chain. Off the top, we have a methyl group, and on the bottom, methyl group. So in the end, off of this second carbon, we have 2 methyl groups. So we've got a 2 and a second 2. They're both off there. And then from there, 2 methyl groups. We're going to call it dimethyl butane. So carbon-wise, 1, 2, 3, 4, 5, 6. So C6 times 2 plus 2, H14. So if we have 2 or more of the same side chain, that's where we get that Greek prefix. That's where that di from dimethyl came from. So as we're working through, we'll do one more. We'll get really complicated on this one here. If we look here, our longest chain all the way through, we've got a methyl group, we've got an ethyl group, another methyl group, and another methyl group. So when we look to do this one, ethyl comes before methyl alphabetically. So our first stop, 1, 2, 3. So 3 ethyl. And then we have 1, 2, 3 methyl groups. The first methyl group is located at the second carbon. The second methyl group is located at the 5th carbon. And the third methyl group is located at that 9th carbon. So since we have 3, it's trimethyl, 3 methyls. And then we had a carbon chain of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, decane. On worksheet 3, we are now introducing unsaturated, or where there is either a double bond or a triple bond, and our new ending ENY or YNE for those endings instead of ane. So this is going to indicate a double or triple bond. So when we're looking through here, we're going to be losing some hydrogen, so our math is going to be a little bit different. So to start us out, we've got 3 hexene. Hexane or hexene now. Hex, 1, 2, 3, 4, 5, 6 carbons. But our difference is now we had the 3 carbon. So carbon 1, 2, at the third carbon is where we start a double bond. And to show the double bond, we're just going to have a second line put in. Now that double bond does eliminate how many hydrogens we can have. So it actually takes 2 less hydrogens. So instead of C6H14, it's now C6H12. If we have octine, it's now instead of a double bond, we now have a triple bond. Oct8, 1, 2, 3, 4, 5, 6, 7, 8. And at the fourth carbon, 1, 2, 3, 4, we now not have a double bond, but a triple bond being formed. Now, when we have a triple bond, we are going to lose 4 hydrogens for each triple bond, 2 hydrogens for each double bond. So when we look at the 2n plus 2 rule, if we had oct 16, or 8 times 2 is 16 plus 2 is 18, but we're going to lose 4. So C8, and then from there we have the 2n plus 2, so 16 plus 2 is 18, but minus 4, H14 now, because we can no longer have hydrogens around that spot. We can have hydrogens, at these different spots here, 3 here, 2 here, but no hydrogens around those. So we lose 2, 4 hydrogens. On this one, we can have a hydrogen and a hydrogen, but we'll lose out there. We'll try one more. 3, 5, 7 dec-triene. So dec 10, but tri says there's 3 double bonds. So dec 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at the third carbon, 1, 2, 3, we have a double bond. 4, 5, 6, and 7, we have double bonds located at each of those spots. So for every double bond, we're going to lose 2 carbons. If we had 10 times 2 plus 2, we'd have 22. But now for each one, we're going to lose 2 hydrogens. So if we have 3 double bonds, we're going to lose 6. So C10, H16 in the end there. On the back side of worksheet 3, going to start into looking at naming a few. First one we've got here, let's do a little 2-methylbutene. So we've got a double bond, and 2-methyl, we have a methyl group. So first off, butene, 1, 2, 3, 4 carbon chain, and off the second 1, 2, we've got a double bond. So that's our butene part. 2-methyl, we have a methyl group off the second carbon. So we just got a methyl into the air there. On our next one, looks a little bit similar, but we're going to start numbering our carbons here. 1, 2, 3, 4. So it goes through this double bond first instead of over to the side there. So 1, 2, 3, 4 is our longest carbon chain. We have over here a methyl group and that double bond. So we need to first off locate where that double bond is off their first carbon. Off the second carbon, we have the 2-methyl group. 2-methyl, and then we have 1 off the first carbon, but 4-carbon chain, and ene for being a double bond on that butane chain. We got 1, 2, 3, 4, 5 carbons, C5, times 2 plus 2 is 10, 12, minus 2, H10. Try one more. So we need to first off find longest carbon chain. So 1, 2, 3, 4, 5, but we want to start numbering so that we start with the lowest number first in our side chain, the ethyl group. So that ethyl group comes at the 3 ethyl, and then from there, 1, where the double bond starts at, in our 5-carbon chain pentene. So 5 plus 1, 2, 6, 7, C7, H14 plus 2, 16, but we lose 2, H14. So as we're working through, that's just going to help us out working there. Octadiene, 8 carbons, 2 double bonds, 1 at the second and 1 at the fifth, and then a third ethyl group. So as we're working through, 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 2, 5, second carbon, double bond, fifth carbon, start that double bond, and at the third carbon, 1, 2, 3, would be an ethyl group. So as we're working, that's going to just help us out. Worksheet 4 is kind of a little bit of review. State what is wrong with each structure that was drawn. One of these is correct. So as you look through these 4 structures, one of them is correct and the rest of them there's something wrong. I'll give you a clue. 1, 2, 3, 4, 5, 6, 7, 8. This one is correct. It's just weird looking having them this way. The other 3 are incorrect. On the second set, state what is wrong with each name. One of these is correct. You don't have to fix it, but the other 3 you have to fix. In our last section, section 10.5 worksheet has isomers. Isomers, same chemical formula with different chemical structures. All of these are octanes or 8 carbons with 18 hydrogens. So every one of these, A, B, C, D, all the way through O, or all through the end of them, all have C8 forms, but they have a different arrangement. So when we look through, if we were to find like octane, on here somewhere, there's one that has all 8 carbons in a row. So G, octane. From there, we need to start looking 2-methylheptane. One of these has a methyl group on the second carbon and a 7-carbon chain. All the way at the bottom, 1, 2, 3, 4, 5, 6, 7, with the methyl group would help us out there. From there, 3-methylheptane. Very similar, 3-methylheptane. Need to find one that's 1, 2, 3, 4, 5, 6, 7, but now that methyl group is off the third carbon. So that's going to kind of help us out as we're going forward. You'll need to start looking through and reading through to find out which one matches with the rest of those. But we're going to give you rest of time. Hopefully this helped out on working through our organic chem problems.